हेलो एवरीवन, गुड इवनिंग, कैसे हो? हेलो एवरीवन, कैसे हो आप लोग?
हेलो एवरीवन, गुड इवनिंग।
चलो, so we are going to continue this series. Yesterday we solved questions on zeroth law. So what was the session yesterday? Yesterday we started with our discussion on zeroth law, and now today we are going to discuss work and heat transfer part 1. Work and heat transfer part 1, and the same discussion we are going to continue because we all know work and heat transfer have many questions. It is one of the most important topic from thermodynamics basically. So we will take 2 sessions so that I don't want to leave anything behind. Okay, so we'll have 2 sessions and then we will go to first law for closed systems. So check out this calendar. I have already pasted this in my Telegram group. If you are in my Telegram group, then you are already aware with my schedule. Yes. So make yourself aware with this schedule and try to join the classes live, because that is the most important thing. Okay, and also there are other YouTube sessions on 10th and 16th where we will be solving a new series we are starting, and we'll be solving old questions which are old but it's still relevant. Okay, and guys, these from white you can see my app sessions. So these are basically my app sessions on 6th and 7th 2021 and 22, 27, 28 and 29. So these are for PSU. If you are targeting PSU, then you can join these sessions. PSU and ESC level questions we are going to do in free app classes. So, and guys, if you want to join these classes, you can download the app by either scan this QR code or by typing in this link. Okay, or you can also, you can see this link, below this video you can see this link. You can directly click and go and download the app if you want to join my classes and anyone's classes. Basically all the faculty are there. And guys, if you are still struggling to finish your syllabus, then we have started the crash course. You can join it. We are not leaving anything. Every element that is required for your GATE exam preparation we have added in this. So we have live classes, recorded lectures, study material, practice quizzes, mock test, everything. And we are also starting soon batches for GATE 2025 and 26. If you are actually serious about the preparation, then you will have a right time to join these batches 2025 and 26. Everything, every element that is required for your GATE preparation is included in these batches. Okay, so you can call on this number and ask about the details. When are we starting? How are we starting? How are we planning? When are we going to finish? How many mock tests? How many, whatever you want to know, you can ask them. Also, as I told you, all the information is already there on the app. So you can download the app directly and all the information will be available to you, will be accessible to you. And you can download the app by clicking on this link that you can see on this below this video. Okay, chalo. And guys, yesterday also I shared my PPT after the class in this Telegram group. Today also I am going to do the same. So if you want to connect with me, if you want my PPTs, if you want my material, if you want to ask any questions, if you want to connect with me anyway, so you have to join this Telegram group. That is the only way to communicate with me. So you can either scan this QR code or you can search in mechanical by Vipin Yadav or see my photo and join this Telegram group. Okay, chalo start karte hain session. Let's start the session by a quick introduction. If you know me, well and good. If you do not know me, let me give you a brief idea about my profile. So I have 6+ years of teaching experience. I have taught for GATE, ESC, AE, JE, PSUs, everything. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano, Italy. I have 3.5 years of industry as well as research experience. and my area of expertise is basic and applied thermodynamics and heat transfer. चलो स्टार्ट करें क्या, यस और नो? अरे बोल दो भैया कमेंट में, किया जाए स्टार्ट। चलो स्टार्ट करते हैं। पहला क्वेश्चन, फर्स्ट क्वेश्चन, बहुत आसान क्वेश्चन से स्टार्ट करते हैं, स्लोली विल मूव इन द डिफिकल्ट पार्ट ऑफ इट। ठीक है, क्या कह रहा है पहला क्वेश्चन? व्हाट इज दिस सेइंग? अ पंप, वी हैव अ पंप, इज फोर्सेस 1 मीटर क्यूब पर मिनट, यानी कि वॉल्यूम फ्लो रेट is 1 meter cube per minute of water horizontally from a open well to a closed tank where the pressure is 0.9 megapascal. So what is the pressure? 0.9 megapascal. And from where? It is open well, that means initial pressure is atmospheric 1 bar or 0.1 megapascal, let me say. And P final is 0.9 megapascal. Now they are saying compute the work the pump must do upon the water in an hour just to force the water into the tank against the pressure. Good evening, good evening. कैसे हो? So when this pump is pumping this water from an open well which is at atmospheric pressure to a pressure of 0.9 megapascal in a closed tank, how much work will this pump do per hour? First thing. Second thing, instead of pumping it there horizontally, if we are pumping it at a height, if the work done as above upon the water had been used solely to raise the same amount of water vertically against gravity without change of pressure. Pressure we are not changing. Pressure remains same 0.9 megapascal. So how many meters would the water have been elevated? Second question. Third, if the work done in open is upon the water had been used solely to accelerate, यानी कि you are increasing velocity only. Any? If the work is done upon the water had been used solely to accelerate the water. So we are only using this work to accelerate the water without change of pressure or elevation. यानी कि now you are not changing horizontally, you are not going vertically, you are giving all the work for increase in kinetic energy. Then what will be the final velocity I need to tell if initial velocity is 10 meter per second. So let's try to do the question one by one. Okay, first part, A part. Volume flow rate is 1 meter cube per minute and initial pressure is 0.1 megapascal and final pressure is 0.9 megapascal. अरे बाबा टेलीग्राम पे कनेक्ट हो जाओ। अब यहां पे क्या गाइडेंस देंगे? ये सब इसलिए टेलीग्राम है। कनेक्ट ऑन टेलीग्राम, वी विल डिस्कस देयर एवरीथिंग। ओके, यूट्यूब सेशंस आर फॉर डिस्कशंस दैट वी डू। आई मीन दिस पर्टिकुलर सेशन इज डिजाइंड फॉर अ पर्टिकुलर डिस्कशन, राइट? ठीक है, तो जो डाउट है, जो क्वेश्चन है, टेलीग्राम पे कनेक्ट हो जाओ, वहां पे एक बार मुझे टैग कर देना। कॉल पे बात कर लेंगे, टेलीग्राम पे बात कर लेंगे, जैसा मर्जी ऐसा कर लेंगे। ठीक है, क्या निकाल लिया? 0.8। कैसे निकाल लिया? चलो, कैलकुलेट वर्क डन। नाउ वर्क डन वी ऑल नो। वर्क डन इज व्हाट? वर्क डन इज व्हाट? वर्क डन इज इंटीग्रेशन वीडीपी। Now if it is volume flow rate, so it will be in kilojoule per minute. Okay. Now, so when we integrate, why volume remains same, volume flow rate is same. So I can say it is 1 meter cube per minute into 0.9 minus 0.1 into 10 to the power 3 kilopascal. Kilopascal. So calculate how much is this. Calculate how much is this. It is 0.8 kilojoule per minute. Kilojoule per minute. But they are asking in an hour, यानी कि 1 minute is this. 1 minute is this. Yes. In 1 minute, this much work you need to give. How much work you need to give in? How much work you need to give? In 1 hour. So, into 60 minutes per hour. So, you can calculate 48 किलोजूल पर आवर. 48 ही आएगा ना ये, कितना आएगा? Yes or no? Yes, 48 kilojoule per hour. Good evening, good evening. चलो नेक्स्ट करते हैं. नाउ सेम वर्क, यानी कि वर्क इज 48 किलोजूल पर आवर. 48 किलोजूल पर आवर. 1 second. 0.8 into 10 to the power 3. This is 800. Into 60. 48 into 10 to the power 3 kilojoule per hour. Kilojoule per hour. But we can find out kilojoule per second as well. How? Just divide by 3600. So they are asking this. But to calculate power, power is always in what? Kilojoule per second, यानी कि kilowatt. So it is 13.33 kilowatt. Power is 13.33 kilowatt. Right? Now, if the work done is given upon the water had been used solely to raise the same amount of water vertically against gravity without change of pressure, how many meters of work has been elevated? How many meters? Now you see, this work I have given to raise the pressure to how much? Pressure to 0.9 bar. यानी कि now what do I have? I have 0.9 bar of pressure. By work is converted to pressure, right? I have given this work to convert into pressure. So at this pressure is equivalent to what height? How can I calculate? This pressure is equivalent to what height? P is equals to rho G H. P is 0.9 into 10 to the power, it is megapascal, right? Ten to the power 6. Density is how much? Density is 1000 into 9.81. So you can raise to this height. Calculate what is this height. Express units is what? Express units in watts, V8, W8, TTS. Is it watts or something else? What is the height, guys? What is the height? How much height you can push this water? This pressure is equivalent to what? (917). Is it 917 or 91? (91.7) है मनिकेत. So the same work can be utilized to increase the height to 91 meters. 91 meters. Okay. Now, if you are giving the same amount of work, if you are giving the same amount of work to increase the velocity, then what will you do? By the same amount of work is going to increase the velocity. So what is in kinetic energy? Kinetic energy is equals to, sir, m v2 square minus v1 square by 2. Yes or no? Now I am giving this work to convert into kinetic energy. Convert this into kinetic energy. I am going to increase the kinetic energy by using this. ठीक है? So work is what? By can I say work is V delta P, and what is mass? Mass is density into volume. V2 square minus V1 square by 2. ठीक है? Now V1 is given to me. V1 is given to me. I need to find out V2. Or you can directly write down work, no problem. Whatever you want. Here I just want to cancel it. That's why I wrote it like this. Now delta P is 0.9 minus 0.1 into 10 to the power 6 is equals to 1000 into V2. I need to find out. V1 is given 10 meter square. 10 meter per second. Calculate V2, Baba. Calculate V2. How much is V2? टेन टू द पावर 6 होगा ना, क्योंकि देखो वेलोसिटी काय में होती है? वेलोसिटी इज इन मीटर पर सेकेंड. So whenever velocity is there, you need to take pressure into Pascal. Otherwise, what you do if you want to take pressure into kilopascal, then you need to divide velocity by, जैसे यहाँ पे 2 है ना, तो you need to do 2000. 2000. Okay. Got it? What is the answer? What is the velocity? What is the velocity? I am getting 41.23 meter per second. Are you getting this? इतना तो नहीं आएगा यार, मैंने कैलकुलेट किया है अभी. I have calculated 41.23. Same equation I have put. Just recalculate it again. Anu, I don't understand what you are saying. It's BOT bot. चलो कर लो फटाफट, आगे बढ़े. लेट्स मूव अहेड. चलो guys, first of all try to understand the question. ओके वेरी गुड. ठीक है, चलो आगे बढ़ते हैं. द पिस्टन ऑफ अ ऑयल इंजन of area 0.0. So I have an engine. And I have a piston. The area of this piston is 0.0045 meter square. And it moves downward. हाँ डायरेक्ट पुट कर सकते हैं, डायरेक्ट पुट कर सकते हैं. Then just you have to put volume flow rate here. That's all. I wanted to cancel volume flow rate. That's why I just did that. Okay. You can directly put work. Yes, of course you can put. Okay. Now, and it moves downward to 75 millimeter. So it comes here. So travel is how much? 0.075 meter. Drawing in 0.00028 meter cube of fresh air. How much volume has entered? 0.00028 meter cube from the atmosphere. The pressure in the cylinder is uniform. Pressure remains same. Pressure is equals to 80 kilopascal. Estimate the displacement work done by the air finally in the cylinder. I have no knowledge of that, Anu. I am sorry. I have no knowledge of board of trade. Okay. I really don't know. ठीक है. Let's discuss what we are discussing. Okay. चलो. Now, so they are asking this piston displacement work. Piston displacement work. And do you all know what is piston displacement work? Do you all know what is piston displacement work? By piston displacement work. Yes, very good, very good. It is PdV, PdV, PdV. And what is the change in volume? By pressure is 80 kilopascal. Change in volume is what? Area into length. Area into length. So 80 into 0.0045 into 0.075. If you calculate that, you will get how much? You will get 80 into 0.0045 into 0.075. 0.027 kilojoule. 0.027 kilojoule is the piston displacement work. Clear है? इतना कैसे आ गया मनिकेत? इतना कैसे आ गया बाबा? let's go to next question. A engine cylinder has a piston area, यानी कि area of piston is given how much? 0.12 meter square and contains gas at a pressure of 1.5 megapascal. Now the gas expands according to the process which is represented by straight line on a pressure volume diagram. Now so if this is P1, your final pressure is 0.1 megapascal, 15 megapascal. And how you are going from this to this? You are going from P1 is equals to 1.5 megapascal to P2 is equals to 0.15 megapascal. This point you are going by a straight line. You are going by a straight line. Yes, 0.027 is the correct answer. ठीक है, चलो. So this is your initial pressure and this is your final pressure. This is your initial pressure and final pressure. Now the gas expands through this. Now they are asking, calculate the work done on the piston if the stroke is 0.3 meter. Stroke means length, यानी कि change in volume. So भैया change in volume will be how much? Area into length. Area is how much sir? 0.12. Length is how much? 0.3. कितना आ गया change in volume? What is the change in volume? कितना आ गया change in volume? 0.036 मीटर क्यूब आ रहा है इतना. किसका इसका बता रहे हो क्या? 48.6. अभी देख लेते हैं. चलो, तो चेंज इन वॉल्यूम कितना है? इतना. अब इफ आई नीड टू फाइंड आउट द वर्क, हाउ कैन आई फाइंड आउट द वर्क? इफ आई नीड टू फाइंड आउट द वर्क, हाउ कैन आई फाइंड आउट द वर्क? भैया एरिया अंडर द कर्व विल गिव मी वर्क. एरिया अंडर द कर्व विल गिव मी वर्क. एरिया अंडर कर्व विल गिव मी वर्क. So area under curve is equals to work done is equals to 1 upon 2. How can you calculate area under work? P1 plus P2 into V2 minus V1. If this is my V2, this is my V1, so V2 minus V1. If you calculate, you see, if you calculate area of triangle and area of rectangle, then you will get this expression. So if you get this expression, directly write this expression. You can do area of triangle plus area of rectangle, still you will get the same answer. Still you are going to get the same answer. Okay, you can try that yourself. Now, half 1.5 plus 0.15 into 0.036. How much is the answer? How much is the answer? (0.0297 megajoule. Yes or no? Yes or no? 48 कैसे आ रहा है भैया? कैसे निकाल दिया 48? हाउ डिड यू गेट 48? हाउ डिड यू गेट 48? क्लियर है? Yes, kilojoule it is 29.7 in kilojoule you can find out, of course. I have written in megajoule. ठीक है, चलो a mass of 1.5 kg of air is compressed in a quasi-static process from 0.1 megapascal is equals to P1 to 0.7 megapascal is equals to P2. How? PV is equals to constant. कौन सा प्रोसेस है PV is equals to constant? Which process is there PV is equals to constant? Which process is PV is equals to constant? The initial density of air is this. So initial density is 1.16 kg per meter cube. Find the work done by piston to compress the air. What is this process PV is equals to constant? अरे आइसोकोरिक बोल रहे हो क्या? हैं? आइसोकोरिक बोल रहे हो क्या? बहुत गलत, बहुत गलत। कौन सा है प्रोसेस? आइसोथर्मल। आइसोथर्मल है। और कैसे हाउ डू वी फाइंड आउट वर्क डन इन आइसोथर्मल प्रोसेस? P1 V1 ln P1 by P2. Yes or no? Now I know P1. P1 is 0.1 into, let us say, 10 to the power 3 into volume. Now how can I find V1? Array, mass is given, density is given. Mass is given, density is given. So mass per unit density is my volume. ln P1 is 0.1 upon 0.7. Whatever you are going to get, you will get in kilojoule. Tell me how much is it? कितना आ रहा है? कितना आया? कुछ भी, कुछ कैसे करते हो यार मनिकेत, कैसे करते हो? I have just calculated by using the same equation. I don't know how you do these things. Please focus on your calculations. It's very important, Baba. Anyone else? How much are you getting? 251 is correct. 251 is correct. 251.67 kilojoule, that too minus. So it is work of compression. It is work of compression to minus. This equation will automatically give you minus if it is work of compression. क्लियर है? क्लियर है क्वेश्चन? मनिकेत कैसे सॉल्व कर रहे हो बाबा? चलो, now this you can do in homework based on the same concept we have discussed. Based on the same concept that we have discussed, this you can do in homework. I will share the PPT in my Telegram group. Okay, I will share the PPT in my Telegram group. Try this question on the same concept that we have discussed. What is this process, Baba? Polytropic process. So I hope that you remember how to calculate work in a polytropic process. If not, go to the concepts where, if you have studied with me or you have made your own notes, if you don't remember, go to the formula or your short notes table and find out what formula you use to calculate work for polytropic process. Okay, chalo, let's go to next question. Now, a single cylinder यानी कि n is equals to 1, double acting k is equals to 1, basically k is equals to 1, double acting means both side compression, both side expansion. Reciprocating water pump has an indicator diagram which is rectangle. So I have a indicator diagram PV, it is rectangle. .0.075 and height is 0.05. So what does this area gives me? This area is equals to 0.075 into 0. This is the area of the indicator diagram. Area of the, तो भैया प्रैक्टिस करो, बहुत जरूरी है. मनिकेत, आई हैव सीन यू मेनी टाइम्स, you know things but still you do wrong. Calculation is something that you need to work on. Okay, chalo. The indicator spring constant K is equals to 147 megapascal per meter. The pump runs at N is equals to 50 RPM. Pump cylinder dia is this, यानी कि dia is 0.15 meter and length is 0.2 meter. Find the rate in kilowatt at which the piston does work on the water. So what you need to find out? You need to find out indicated power. And we give indicated power as, अबे क्या हो गया, इतना इमोशनल क्यों हो रहे भैया? थैंक यू सो मच. चलो, PM mean effective pressure into length into area into N by 60. If 2-stroke engine है then 60, if 4-stroke engine then 120. Do you all know this formula? Now see, and because it is double acting, so we have to multiply this by 2n. ठीक है, चलो. So indicated power is equals to PM. What is length? 0.2. What is area? Pi by 4d square. 2 into 50 by 60. By 60. Now sir, how will you calculate mean effective pressure? How will you calculate mean effective pressure? So mean effective pressure is given by, when spring constant is given, when spring, it is given by area by length. Area by length. Area of the indicated diagram by length of the indicated diagram into spring constant K. Into spring constant K. So tell me what is mean effective pressure? Area is 0.075 into 0.05 upon length is 0.075 into 147. Tell me how much is it? How much is mean effective pressure? One 47 into 0.05 7.35 मेगा पास्कल. चलो रख दो यहां पे फटाफट. रख दो ऊपर वाली इक्वेशन में. 7.35 into 10 to the power 6. 10 to the power 6 into 0.2 into 0.285. What is pi by 4? 0.285. I think that is correct. Calculate quickly. Calculate quickly. Okay, 0.785. This is 0.785. Sorry. Pi by 4 is 0.785. चलो निकालो जल्दी. 0.2 into 10 to the power 6 into 7.35 into 0.15 square into 2 into 50 divide by 60. कितना आ रहा है? कितना आ रहा है? 43295.0 जूल्स. यस. और 43.29 सॉरी वॉट. यस, वेरी गुड. वॉट कितना आया? 43.29. वेरी गुड, वेरी गुड. ओके उदय, वेरी गुड. आ गया ये क्वेश्चन समझ में? क्वेश्चन आया समझ में? गाइस ये पी के नाम अगर कर लोगे तो थर्मोडायनेमिक्स में कोई नहीं रोक सकता. इतना ध्यान रखना. पी के नाग is the one stop solution for thermodynamics. It opens so many concepts if you just focus on P के नाग from numerical point of view, from practice questions point of view. Okay, and I will try to bring as many sessions as possible, and I will try to do all the topics in P के नाग. Okay, so keep joining. चलो next question. Similar question. A single cylinder, single acting. Now N will be equal to simple. 4 stroke of dia कितना है? Dia is equals to 0.15 meter. Develops an indicated power of 4 kilowatt when running at 216 rpm. Calculate the area of indicator diagram that would be obtained when an indicator having a spring constant. Spring constant is how much? K is equals to 25 megapascal. 25 megapascal. Or you can say 25 into 10 to the power 6 Pascal. Simple. The length of the indicator diagram is, so length is equals to 0.1 times of length of stroke. 0.1 times of length of stroke. Yeah, same question, a little bit concept is going to change. Same formula. What? Sir, indicator diagram is equals to mean effective pressure into एल एन ए एल एन इंटू ए एल एन। बाई 60 आएगा 120 आएगा? 120 because 4 stroke. Now this is given as 4 kilowatt. This will be, just now we have seen area of indicator diagram by length of indicator diagram into K into area. This is what? This pi by 4 d square into length. What is this length? L, length of stroke, into n by 120. Now they are saying, sir, this length is equals to 0.1 ls. That means this and this will get cancelled. I need to find out area of indicator diagram. So I will say 4 into 0.1 into 4 into 120 upon pi into k into d square into n. I know everything. बुक क्वेश्चंस का पीडीएफ नहीं है बाबा, बुक है मेरे पास। मेरे पास बुक है, वो मैं वो शेयर कर दूंगा टेलीग्राम में, ठीक है। नाउ कैलकुलेट क्विकली 0.1 into 4 into 120 upon pi. K is how much? 25 into 10 to the power 3 into d 0.15 square into n 216. Calculate quickly how much you are getting. कितना आ रहा है? आ रहा है इतना? नहीं आ रहा? आ रहा है 0.005 और एक दो जीरो आएंगे बाबा, 3 जीरो आएंगे, 3 जीरो आएंगे जब 5 आएगा। चलो नेक्स्ट क्वेश्चन देखते हैं। इंपॉर्टेंट क्वेश्चन। अ क्लोज सिलेंडर of 0.25 meter dia is fitted with a, so I have a closed cylinder with dia how much? Guys, important question है, focus is fitted with a frictionless, light means massless, frictionless piston. The piston is retained in position by a catch on one side of the piston contains, so here the pressure is 750 kilopascal. The volume on the other side is evacuated. Now a helical spring is mounted coaxially with the cylinder in this evacuated space to give force. Initial force कितना लग रहा है इस पे? 120 न्यूटन. Initially force कितना लग रहा है? 120 न्यूटन. When you are here, force is 120 Newton. The catch, now you remove this stoppers. Now you remove this catch. Okay. Now you remove this catch. And then piston travels along the cylinder until it comes to rest after 1.2 meter. That means piston moves up. Piston moves up and it comes to rest here. How much it has traveled? 1.2 meter it has traveled. The piston is then held in its position of maximum travel by a ratchet mechanism. So now again you stop it. Again you stop it. The spring force increases linearly with the piston displacement. That means if I need to draw my force and displacement, then it is linearly increasing. So how is it increasing? Linearly to a final value of 5 kilonewton. So see, by here x is equals to 0. Here x is equals to 1.2. To 0, let us say here at x is equals to 0, force is what? 120 Newton, 120 Newton. And when x is equals to 1.2, force is 5000 Newton, 5000. Now what are they asking? Calculate the work done. करो सॉल्व. कितना आ रहा है? करो कितना आ रहा है? दो तरीके से कर सकते हैं इसे. दो तरीके से कर सकते हैं. पहले तो क्वेश्चन समझना ही जरूरी है. ठीक है. अब जब समझ आ गया तो वर्क डन आ गया मेरा सर हाफ क्या आएगा? F1 प्लस F2 इंटू डेल्टा एक्स. $5000 प्लस 120 इंटू 1.2. कर लो कैलकुलेट. कैलकुलेट कर लो. हो गया. एक तरीके से और कर सकते हैं. एक तरीके से और कर सकते हैं. कैसे कर सकते हैं? बाई दिस. व्हाट इज द रिलेशनशिप? y is equals to ax plus b. Yes or no? So can I write f is equals to ax plus b? So by what is the force equation? What is the work done? Work done is equals to by force into dx. F into dx. And force, I need to find out relationship. What is this force? Ax plus b. So I need to find out A and B value. How can I find out A and B value? By force is equals to Ax plus b. Now I have two conditions. First condition is when force is 120, x is 0. X is 0. So from here b is equals to 120. Second, when force is 5000, x is 1.2. Now b we already find out 120. So how much is A? How much is A? How much is A? 5000 minus 120 divided by 1.2. 4067. So now my equation of F is equals to 4067x plus 120. So this is my general equation. How this is changing with respect to x. How this is changing? How it changing? 120 plus 4067x. That is how it is changing. Now I can find out x at every point, and then I can find out area. So what I need to do? I will just integrate it from 0 to, I will integrate it from x1 to x2. 4067x plus 120 into dx you do, and this is 4067 x square by 2 plus 120x x1 x2. So x1 is what? 0. This is 1.2. So you can substitute. When you put 0, it will be 0. But I can do 0.67 into 1.2 square by 2 plus 120 into 1.2 minus 0, minus 0. So work done can be found out as how? How can we find out how much is the work done? Same work done you are going to get 0. This. Same work done. No change in work done. Yes or no? आ गया समझ में? चलो, तो ये हमारा लास्ट क्वेश्चन था. एक क्वेश्चन होमवर्क के लिए दिया है, सॉल्व कर लेना. आसान क्वेश्चन है, वेरी इजी क्वेश्चन, वेरी इजी. जस्ट ट्राई इट. एंड गाइज, डू नॉट मिस द अदर सेशंस, डू नॉट मिस द रेस्ट ऑफ द सेशन. make it a continuous habit to join these sessions. Okay, you see, now the next session of work and heat transfer problem session, PK Nag, is on 8th of November. The next session is on 9th of November. हाँ, लेकिन बाबा बात यह है कि प्रोसेस पता होना चाहिए. ना सॉल्व करो तो अलग बात है, बट पता होना चाहिए. दैट इज द मोटिव. अंडरस्टूड? So guys, do not miss these PK Nag sessions, and these are my YouTube sessions. Do not forget to join me on app. How can you join the app? By clicking on the link. By clicking on the link. And guys, we are again coming up with a very wonderful series very soon, and that is old is gold. Handpicked questions, PYQs from early 90s. पुराने जो हो गए हैं, पुराने old questions, but they are still relevant. Very good questions, handpicked questions. Okay, so do not forget to join us on YouTube from 6th of November. And on 8th of November, 7:30 p.m., Joseph sir is coming live for you with the workshop roadmap to secure AIR under 100 in GATE 2025. So do join this, and also you can, if you want to join our new batches GATE 2025-26, then you can get up to 90% of scholarship, and the scholarship test is on 5th of November 9 a.m. to 9 p.m. You can sit anytime, but day is fixed, 5th of November. Okay, chalo. And guys, as I have said this many times, mock test is one of the integral part of your preparation. Your preparation is incomplete until you give at least 8 to 10 mock tests. Okay, and you can join it anywhere, but we are also started mock test series where we have 4 part test and 4th full length test. So you can join this series as well. Okay, chalo. So very good guys, very good. Let's meet in the next session very soon. And guys, keep up the momentum. Keep up the momentum. GATE is just here. If you stop now, then everything what you have done is gone to waste. So keep up the momentum. Keep practicing. Keep revising whatever you can do to push yourself till Feb. Okay, chalo. Okay guys, thank you so much. I will see you very soon in one of the next sessions. Bye bye.